Have you ever wondered how secure your Wi-Fi really is? In today's world, a weak Wi-Fi setup can leave your personal data wide open for cyber attacks. But don't worry, in this video, we'll show you how to turn your basic SOHO router into a digital fortress. From mastering WPA2 encryption to using WPS for quick, secure connections, you'll learn how to protect your network like a pro. Stick around, because securing your Wi-Fi has never been this simple, and your data depends on it. SOHO router and Wi-Fi encryption. In this course, we're going to talk about SOHO routers and Wi-Fi encryption. SOHO stand for small offices like home offices. When we say the term SOHO, it simply means that it is a small office router at home. These are routers that do not cost very much and that you can use at home or in small businesses. Plus, they're easy to set up. But on the other hand, if you don't configure it, then you won't be able to access the network or even the internet. To install and configure your small router, you'll need to go to the router's built-in web page. For example, here we have a Cisco laptop and Wi-Fi router. The laptop has therefore hooked up the router and Wi-Fi. So, we will open a web browser and enter the router's management IP address. It is the IP 192.168.0.1. We validate by entering, and we are asked to enter the credentials to access it. You enter the router's login and password, and you arrive on its configuration page. This is where we can configure it to run on our network. For example, we see that the Wi-Fi router has a built-in DHCP server, and that it is capable of distributing addresses ranging from 192.168.0.100 to 149. It is thanks to this DHCP that the laptop was able to recover its IP in point 100. So, by default, the DHCP server is enabled if you want. You can simply disable it by clicking on Disable in the DHCP settings. If we click on the next tab, we have the wireless settings. This is where you can configure the SSID, Service Set Identifier, which is essentially the name of your wireless network. This ID is shared with all devices that are wireless and is customizable. That is to say, you can rename it as you want. In the example, the SSID is called Home Router. This means that any wireless equipment, as long as it is near the Wi-Fi router, will see the broadcast of the SSID, which is called the home router. And if the equipment also has the login credentials, then they will be able to join the Wi-Fi router network. You can also set the wireless network channel. The channels are used to avoid interference with other wireless networks, which would be nearby. So, if you're having connectivity issues with your wireless router, it's likely that there's interference with another network or wireless equipment that is nearby and running on the same channel as yours. The ideal, in this case, is to try to change the channel and see if it solves the problem. Now, let's move on to the Wireless Security tab. This is the place where one can configure the Wi-Fi key and choose the data encryption method. If you want, you can even turn off security and open up the wireless network to everyone. And you can also, of course, protect it with a password, with one of these different security modes, WebKey. As can be seen, this router supports the following modes: WEP, Wired Equivalent Privacy, WPA, Wi-Fi Protected Access, and WPA2, Wi-Fi Protected Access 2. Initially, WEP encryption was supposed to provide the same security as in wired networks. But it was a failure because shortly after its release, it became very easily hackable. That's why WPA encryption came along. WPA was designed primarily to address WEP security issues. WPA is therefore much better than WEP, especially on 2 points. First, it uses the Temporal Key Integrity Protocol, TKP encryption method. This is a protocol that will allow you to dynamically modify your encryption keys while in use. This ensures data integrity. And second, WPA uses the Extensible Authentication Protocol, EAP, which verifies that network users have permission to communicate on the network. In fact, it is simply an authentication method. Now let's move on to WPA2, which has been developed to provide even stronger security than WPA. It provides an even more advanced encryption method than the first version. This is the CCMP, Counter Mode CBC MAC protocol, which is also known by the initials AES CCMP, Advanced Encryption Standard Process, Counter Mode CBC MAC protocol. It's an encryption mechanism that replaces the WPA1 TKIP, and which is obviously much more secure. Very recently, since 2018, the Wi-Fi Alliance, which is an organization that owns Wi-Fi, announced the WPA3 security protocol. This new method of data encryption is even more reliable than WPA2 and old security protocols. Eventually, WPA3 will completely replace WPA2 as it brings many improvements that make it very difficult to guess passwords. WPS, Wi-Fi Protected Setup. Another wireless security protocol is WPS. It was designed for users who don't know much about the wireless network to make it as easy as possible for them to connect. And this is what the WPS configuration page looks like on our router. As you can see, there are 3 different methods of WPS to enable joining the wireless network. The first method is the simplest. It's the one we use at home when we want to connect to our internet box. Here, all you have to do is press the WPS button on the equipment you want to connect to the network, and within 2 minutes, press the WPS button on the router. The second method is to enter the PIN code of the device that wants to connect to the router. And the third method is the opposite of the second method. Here, you choose a PIN code to configure on the router, and the wireless equipment will have to enter it to connect to it. This is the PIN code that is usually displayed on the label of your router. WPS is therefore the easiest way to join a wireless network. Many manufacturers add this feature to their wireless products, so customers can connect their device to a wireless network very easily. Filtered MAC address. We will now see another wireless security feature, which is filtering by MAC address. Each network device must have a MAC address. The MAC address is a hexadecimal number that uniquely identifies each device on a network. And with MAC address filtering, well, you can prevent or allow access based on the MAC address of the wireless equipment. In the example, once we have enabled filtering by MAC address, well, we can list the devices that will be allowed to access the wireless network. Here, we have authorized the laptop by its MAC address. If we had chosen the top option, well, we would have prevented the MAC addresses on the list from joining the wireless network. Before we finish the course, we're going to talk about DMZ, Demilitarized Zone. The DMZ allows a computer on your network to be fully exposed to the internet. It is the router that directly forwards all the ports to the PC in DMZ. This means that our 2 computers on the left are protected by the firewall, but not the bottom PC because it is located outside the firewall. He is therefore not protected. Typically, the DMZ is used for testing. For example, if you're having problems setting up apps with security rules on a PC that needs to be accessible via the internet, well, you can put it in DMZ temporarily to make sure everything works until you can identify the problem you're having. The last thing to note is that a PC in DMZ will need to have a static address. That is, not provided by a DHCP server.